Hello. In this lesson, we talk about something called the range and population variance. Essentially, what our goal is to determine is how variable our data set, how consistent are the points in our data set. So we'll start with an example context. The situation here is an NFL team is debating between two running backs to draft for their team. The number of rushing yards for each players, all 5 of their home games from the prior year are shown below. Which one should they pick? So option A or option B. What type of calculations do you think the NFL owners and the coaches would do? Well, they would probably calculate the average to start off. And when they calculate the average, they find that A has an average of 83 and B has an average of 84, so nearly identical average, but you'll see that the way that they got to their average are drastically different. You'll see that A has its numbers are more closely grouped together, whereas B has some high and some low numbers, but not actually a lot that are around their average values. So maybe the last thing they would do is determine the variability, like an average distance from the mean. So how are we going to calculate the variability, how consistent the data sets are? Well, there are a variety of ways to do it. The first way is to determine what we call the range, which is the difference between the max and the minimum data entry in the data set. You can also calculate something called the standard deviation, which we'll do on the next slide, but we'll start with the range. So the first thing they might just do is just calculate what the range is, the difference between high and low. For option A, the range would equal the high value of 90 minus the low value of 75. So we would get a range of 15. For option B, the range would equal a high of 160, a low of 40, which gives me 120. And that shows right there the difference in consistency between the two. B is kind of a hot, cold running back, whereas A is a very kind of consistent running back. So that's one way of calculating variability, is we determine what we call the range, maximum minus minimum. The second thing we can do is calculate, which is something called the standard deviation, which is a more involved process, but actually gives much, much better information. So the standard deviation for a population measures how far away, quote unquote, on average, each point is from the mean. The formula for it is given below. So there's two versions. You can do it using the sigma notation, and remember this means the sum, adding up all of. Or you can do it by kind of doing this more drawn out version. So let's just look at what the equation is doing. First off, this symbol that is used is the Greek letter sigma, stands for, it's like an S, stands for standard deviation. Is a symbol we use for the population standard deviation. So what they're doing here is this. If we want to find how on average far apart each number is from the mean, this is what we do. So x1, x2, xn, each of these that I'll kind of underline in green, those are individual data points. And what am I doing? I'm subtracting them from x bar, which is the average. So I'm subtracting them from the average. So I'm finding how far away each point is from the average. So how far away is x1? Get that number. How far away is x2? Get that number. How far away is xn? Get that number. Well, the problem is some are going to be positive, some are going to be negative, because some are going to be above and some are going to be below. And those are going to cancel each other out and artificially make it be 0. And I don't want to do that. So what we do is we square the items so that all of our distances are positive. So we find how far away each point is from the average, and then we square it. Then we add up all those pieces, and then we divide by the total. That's what an average is. The last thing we need to do, though, is undo for the fact that we've squared each of the individual pieces so that we didn't have positives and negatives canceling each other out. And how do you undo a square? You take a square root. So that's the general theory for where the standard deviation comes from. Here are some observations about the standard deviation, then we'll actually calculate it for our situation with the running backs. So the standard deviation, like I said, is a measure of the variation of the data set about the mean. It has the same exact units as the data points in the data set. So in our case, yards. The standard deviation is always greater than or equal to 0 because we're taking a square root. If you have a standard deviation equal to 0, that means that data set has no variation. Every single point in the data set is exactly the same. As the entries get farther from the mean, the value of the standard deviation is going to increase because you have more variability. So here, let's do a situation of calculating it. Note there is a measure of variability called the variance. It is the squared value of the standard deviation. It is an intermediate step on the way to getting to the more useful standard deviation. So you'll see it in books. All it is, it's the value you got for before you took the square root. So we call that the variance. So let's find the standard deviation for running back A. In order to find the standard deviation, because this is a population with all of their 5 home games, I'm going to do the following. So I use a sigma. You're going to have to write a little bit small. I might even run out of room myself. And it's the square root, because I'm eventually going to square all items, and then I need to undo the squaring. And here we go. So it honestly doesn't matter if you do the mean minus the data point or the data point minus the mean. Maybe just to be consistent, I'll go back and look. It looks like they're doing the mean minus the data point. So the mean here is 83. So I'll start with 83 for all of these. So it'll be 83 minus 75. Then I need to, so this first point is 8 away, and I square it. Plus, next point, 83 minus 80. Square that, because it's 3 away. Then I have 83 minus 85. That's 2 away, and I square that. Plus 90. Or sorry, 83 needs to come first. It doesn't really matter, but I'll be consistent. 83 minus 90. That one's 7 away. Square it. And the last part, 83 minus 85. And then divide by the number. There are 5 games, so divide by 5. Now I'm going to simplify. So, okay, here we go. Square root. This won't be as large. 83 minus 75. So this value right here, that was 8 off, and then I'm going to square it. Plus, this was 3 away, and then I square it. Plus, this was negative 2, and then I square that. Plus, this one is going to be 7, negative, squared, plus this one is negative 2, squared. And then I divide all this by 5. Now I sum the top parts. So here we go. I get 8 squared, so I end up with 64 up top, plus 9, plus 4, plus 49, plus 4. So I get, in total, 130 divided by 5. So 130 divided by 5 is going to leave me with 26. Now I need the square root of 26. And the square root of 26 leaves me at about 5.1. And this is measuring yards. So what we can say is running back A's variability was quote unquote on average based on its standard deviation about 5 yards, 5.1 yards away from the mean of 83. That was how consistent he was, only about 5 yards away on average from the mean. The standard deviation for running back B, we would do the same process. It is fairly tedious, as you can tell. And so I'm going to show you how you can use the calculator to calculate the standard deviation as well. If you look option A, you can check, hey, we got the right one. There's the 5.1 that we had for the standard deviation. So I'm going to show you how to do this in the calculator. So you'll need your calculator. What you'll do is you're going to go to Stat. So you hit Stat. You go to option 1, Edit, and you're going to be entering your data values into L1. As you can see, I already have some data values in there. So I'm going to clear them out. So I hit Clear, Enter. I can do that for L2, Clear, Enter. Now I need to enter the data values for that running back, and I honestly don't remember, so I need to go obtain them. So 40, 120, 40 for the first 3. 40, so 40, 120, 40, and then 60 and 160. Now if I go to follow the directions, to view the statistics, press Stat again, tab over, and then choose 1 and enter. So Stat. Then I'm going to go over to Calc, and you'll see option 1 says 1 variable statistics. We only have 1 variable right now. How many running yards? So I choose option 1. If you're using a TI-83, you just hit Enter again. We know it's asking where we put our list. We put it into L1, and I just hit Calculate. And when I do so, it outputs the data for me. There's the average that we found before. There's the 84. And then there is the standard deviation, the sigma x, the standard deviation of my data points, x. This one turns out to be 48, so it's shown right there. And this is directly displaying, what we saw. Running back B is very far on average away from his mean because his standard deviation is so large, 48 yards. So in conclusion, I guess it depends on the coach organization for which one would pick which running back. On average, look, their means are pretty much the same, but their standard deviations are so much greater. My guess would be most would probably choose A because they have about the same mean, but A is less variable, more consistent. It's nice to know what you're going to get maybe in every game, whereas option B might have some great games and some really not great games at all, and maybe some coaches don't like that variability. It just depends, but now they have the information to make that decision. I'm going to give you a chance to try this. So just to make sure you know how to enter the data set, you get a chance to see, if you did it correctly. So the starting salaries for 10 new hires at each corporation are shown below. Find the mean, the range, and the population standard deviation of each. If you're in class, I'd have half the room do A and half the room do B. You could just do one if you'd like and compare, but pause the video now and I'll show the results. Okay, so the results are as follows. If you graph it, you'd see the following, and then you could go through the calculator steps I just showed to determine the values. So moving on. That is for a population, but as we said, it's rare that you have a situation where you have all the data that you would be concerned with. So maybe, for example, a soda company is choosing between two machines that will both fill up their cans. They take a sample of 5 cans filled up by both machines, and each machine is attempting to fill up the cans to 12 ounces, but it's not perfect every time. Even a machine has some variability. Well, you'll notice there was a key word in this description. That was sample. They took a sample of 5 cans, and we are going to find what the variance is going to be for this. But you'll know, so this is a sample, not a population, and that's important because the goal of statistics is to estimate things we don't know. For example, we calculate the mean of a sample to estimate the mean of the population. So it turns out from statistical theory that the best estimate for standard deviation, the one that most represents what really truly goes on in everyday life, occurs when we calculate our sample standard deviation by dividing by n minus 1 and not n. There's a lot of statistical theory in this. One of the more readily accessible theories or ideas would be that because we've calculated the average, I have one less piece of information in order to determine what the average distance is going to be from the mean. So I divide by n minus 1 instead of n. Biggest takeaway, though, is if you were to do it by hand, you're going to be dividing by n minus 1. We're going to have the calculator do it for us, and we'll just note some of the takeaways from it. But if you look at the two equations, they're nearly identical. The sample uses the sample average. The population would use the population average. The sample standard deviation is going to divide by n minus 1, and the population is going to divide by the total number in the population. Question though for you, if you were drawing from the same population, which will always be larger, the population or the sample standard deviation? How can you look at the equations for these and justify? How could you use some real life common sense to explain? So you can actually look at the equations or use some real life common sense. If you look at the equations, you'll notice that the population standard deviation's denominator is always going to be bigger. So because it's the entire population. When your denominator is larger, the entire fraction is smaller. So the sample standard deviation is always going to be bigger. Another reason for this is kind of more of a real life justification. That kind of makes sense because if you only take a sample, you don't know as much as if you had, taken a census, an entire sample of the entire population. When you don't know as much, your standard deviation, your variability has to be larger. So that's why your sample standard deviation would be larger than your population standard deviation. In terms of calculating it, we can calculate it using the calculator. So because this is a sample, we're going to be using S. So just to save time, you can do it for yourself, maybe treat it as the yo-yo from before that actually will output the values. You go through the same steps. You type each of these data sets one at a time into the calculator and go to one variable statistics and ask it to output the data for you. And when you do so, you'll see the machine 1 has an average of 11.98, and I have to use the sample standard deviation here. Its sample standard deviation is 0.13, which means on average it is about 0.1 ounces away from the actual average of 11.98. You'll notice its population standard deviation is lower because of the reasons that we said. Machine 2, it has an average of 12.26 and its sample standard deviation is 0.05. So it is more consistent. The question is, which one should the company choose? Well, neither of these machines are that great. And the reason why is kind of shown in the facts. So based on the fact that machine 2 consistently overfills, if you look, machine 2 on average is doing 12.26 ounces, so they're giving away kind of free pop because they're only really charging people for 12 ounces. It's consistently doing it because it has a smaller standard deviation. So if they had to choose between the two, they'd probably go with machine 1. Machine 1 is closer to the average of 12, has slightly more variability, but honestly, if it's just 0.1 ounce compared to 0.05, I guess it depends on the professionals in that setting, but might not be enough to really cause an issue. So probably machine 1 if you had to choose. Last one, see how you're understanding the concept of population variance or standard deviation. Which distribution has the larger standard deviation, is more variable? Take a second, look at the two distributions, think about it, give the justification, we'll come back and see. Okay, so let's go over it real quick. So you have to recall that the definition of standard deviation was kind of average distance from the mean. So if I look here, the mean for this is right about here, and the mean for this one's probably, oh, I don't, somewhere around there, right? So if I look, their average is about right around 3, and which one tends to have more of them closer to 3? Well, this one, if I drew in the actual picture, these are more tightly connected around 3, whereas this one right here is actually uniform. So if I go back and draw it in there, it actually doesn't even really have any type of curve to it because it's a uniform distribution. This one has much more variability. There are a lot more points that are close or further away from the average than over here. These are more clustered around 3. And this is kind of is something that goes against people's intuition because they're getting the idea of uniform and variability confused. A is uniform in that each score is occurring the same amount of times, but that is not saying that everybody is scoring around the same score, whereas over here, there are more people scoring closer around the average. So this distribution B is less variable. So because it is less variable, A is going to have the larger deviation. And that is it. Thank you very much. Have a good day and stay curious.